Hey guys, so we just finished that cool activity in class where you had to figure out what was inside your boxes. There's a whole reason for doing that, and part of that is looking into what is an atom, right? How do we know what an atom is? Because unfortunately, this picture right here isn't what an atom looks like, and it's hard for me to be able to show that to you. So, like you did with your boxes, right? What did we do to try and figure out what was inside of them? You shake it, you listen, we're making lots and lots of observations. Well, then from your observations, you have to make inferences, right? And do we ever really know for sure if we're right? We could do some more tests, we could ask more people, run more trials, do all of those things that you want to do. But ultimately, are you ever going to be sure of what's inside your box? The only way you're going to know what's inside that box is if you open it. Now the problem is that an atom is really like this black box, okay? And a black box is any system that has inner workings that cannot be directly observed because it's not possible or feasible, okay? Which is what your boxes in class were supposed to represent. So, like I said, an atom is an example of that. I unfortunately can't show you one. I can't pick it up and hold it there for you. So, when scientists wanted to determine the structure of an atom, it's a really hard thing. How do we do it? Well, they do it a lot like we just did in class. They use empirical evidence, indirect evidence, observation, and then after you make all your observations, the important thing is you have to make an inference, right? And that's the big thing. We have to make sure we understand the difference between an observation and an inference. Okay, what is the difference? Well, obviously, an observation can be with your five senses, what you smell, what you touch, what you eat, which we're not going to do in science. And then an inference is kind of your conclusions that you make based on the observations. So, really a big difference. So, how do we apply that when we're talking about an atom? Okay. Well, when we talk about science and everything that goes along with that, there's lots of different ideas and theories. So, our theory about the atom has really changed over time because our technology has gotten better. So, even though no one's ever seen an atom, we are able to really make some good discoveries about it and come to some good conclusions based on the evidence that we collect. It's really pretty similar to about dinosaurs, right? No one's ever seen an atom, no one's ever seen a dinosaur. We know their existence though, and we can figure that out using our indirect evidence. So, really kind of use that analogy when you're thinking about an atom. I think you all probably agree that there's enough evidence that says there were dinosaurs. So, we have to really look at the evidence for really what is the structure of an atom. Okay? That makes sense? Okay, if you need a little bit more information, pause the tape, look up, black box ideas, or look up definition of a black box or atomic theory at any point as we kind of go through this. You want to make sure you're really checking yourself and understanding what it is we're going over. All right. So let's get a little bit into atomic theory, right, and where it began. Now, the history of this is really a little boring, but it's always important to know where we came from, right, how this theory has evolved over time. So, Democritus, right, ancient Greek philosopher, 460 to 370 BC. So, we're talking about a long, long time ago. Okay, and he decided that there was a limit to how far you could divide matter. You could just keep cutting it and cutting it and cutting it and cutting it and cutting it, and then eventually you would get to a point where you couldn't cut it anymore. Okay? It's kind of like the idea that something just keeps getting divided in half and in half and in half and in half. He thought there was going to be an end point. Okay, my little picture here is showing you, if we were talking about a race, well, the race would never end. Okay, if you kept dividing that distance to the finish line in half forever. So his idea that there has to be some kind of end point was really where he came from. Right, came up with this idea of atomos, right? It's that Greek word that means indivisible. This is actually where we get the word atom that we use today. All right. So, what did he really say? He said that atoms are small hard particles made of single material that's formed into different shapes and sizes. He said that atoms are always moving and they form different materials when they come together. Okay? pretty smart guy for way back then, and unfortunately his ideas weren't really taken very seriously. And the reason they weren't is because there were different philosophers at the time who really didn't agree with this, right? We had Plato, we had Aristotle, and they were much more prominent philosophers, and they really thought that matter could be divided into smaller and smaller pieces forever and ever and ever. Okay, and this was really kind of the view that was accepted by people for, almost 2,000 years. So let's review a little bit. What is an atom? Well, it's the smallest particle, right, that can still be divided and be considered the element. I know you've heard that definition since you were in probably sixth grade, right? So whatever that atom is, if you break it down any smaller, okay, the atom has to be the smallest part. Well, I'm not really making good sense out of that, right? It's the smallest particle that an element can still have. So if I have an atom of carbon, like right here, and I start breaking it down into something smaller than this, it's no longer considered an atom. Hopefully that makes a little bit more sense than what I was saying before. So we can do like a little mini timeline of this. Again, it's boring, I know that, but we have to keep in the back of our mind, like, how are scientific models made? How are we coming to the conclusions that we have today? Where is this information coming from? And it really gives us that perspective of how things have changed so much, and how what your children learn about the atom is probably going to be a little bit different than what you're learning about the atom. Okay, things keep changing. We keep adding to our theories. We keep making things a little bit better as we collect more and more evidence. Okay, so John Dalton comes around 2,000 years later. He's a teacher. Good for him, right? And he kind of brings back Democritus' idea of like an atom being the smallest particle, being indivisible. Did lots and lots of different experiments, and really started talking about how atoms join together to form new substances. Again, an idea he stole from Democritus. Okay, he started seeing that atoms would combine in specific ratios. So he had really three specific ideas. All substances are made up of atoms, which are the smallest particles that cannot be created, divided, or destroyed. Sound familiar? It should. And then atoms of the same elements are exactly alike, and atoms of different elements are different. And atoms join with other atoms to form different substances. All right, so if you need to pause and kind of write this down so that you have that, these are three really important things that he was able to kind of come to a conclusion. So years later, we have J.J. Thomson. Okay, and he is given the credit for discovering an electron. Right? And he used what's called a cathode ray tube, which is this little guy here, which we'll see if it works. Let's see if my link is going to work for you guys. Okay. A little bit better picture for you. But what this ray tube was able to do, if we go back to our, okay, is it was able to send a whole bunch of alpha particles. All right, don't worry if you don't know what alpha particles are. They're just, matter that's kind of getting shot through here. And what he was noticing was that as that current was going through, it gave off rays of negatively charged particles. And if an atom was the smallest thing, what are these charged particles, right? The gas was uncharged, so where did these negative charges come from? And really started questioning whether or not the atom is the smallest thing that we have. So didn't know how the electrons in an atom are arranged. He kind of believed they were mixed throughout an atom. You can see this picture here. This is where we get kind of that chocolate chip and ice cream, or the plum pudding model of the electrons kind of scattered throughout. This doesn't look very good here. I don't know why. Oh, because maybe the picture. There we go. All of those negatively charged particles would be spread out throughout it. Now, did another activity in class where we were looking at the trajectory of a marble. Okay, and all of that kind of ties into our ideas of what Rutherford is going to do. And Rutherford didn't really agree with Thomson's idea of this plum pudding model. So he came up with a different experiment, which I'm going to have you pause, and you're going to read a little article about Rutherford's experiment, and hopefully then come to class ready to talk about what it is that he did, and we'll kind of start off talking about Rutherford's gold foil experiment. All right, I'll see you guys in the morning. Make sure you have good notes based on this so that we can kind of take this discussion to the next level in class.